Hi class, so welcome to our final presentation of the course CS263. Our topic is learning polarity embedding, and what we're going to cover include the background, motivation, and model experimental results. And also we will release our code and our data together with some other related repository links. To begin with, we observe this kind of phenomenon that people from different parties refer to the same concepts using different expressions. And we want to train such kind of model to automatically determine this kind of problem, like automatically learn such kind of difference. And to depict this, we can do it in multiple different ways. Like we can treat it as a problem of topic modeling, of machine translation, and also we can do it by treating it as embedding learning. This is the direction we are going to right now. By treating this as a embedding learning problem, we say that we have a structured embedding, which means that the embedding contains two components. The first component, the second component. The first component is expected to be only capturing the semantic meaning, and the second one is expected to capture only the polarity information. Let's depict it in this way, and so that if we have a pair of words, for example, just the pro-life, pro-choice, then we'll have one of them like this, one of them like that, which means that they have the same semantic meaning, but different polarity meaning, different meaning in the polarity dimension. How to do this? How can we achieve this? This is done by learning the embedding following G and Globe that has learning the objective that has three components. The first component is just the standard globe loose. The second component is has two different versions. One version is so the second component is used to have this gap as large as possible, these gaps. And so the first version, the L1 version, says that I want it to be as large as possible, this difference, as large as possible. And the second version, the L2, says that I want it to be as close as possible to beta 1 and beta 2 pair as possible, which is often set to be -1 and 1 in practice. And the third component of the loose, forces the pairs embedding to be, to force this semantic dimension to be in the null space of this polarity dimension. So this is the basic idea. And what we observe from our experiments is that the G and Globe is probably not enough, because it's really very, very hard to find adequate amount of the polarity pairs for the political data set. You can imagine how difficult it is. Like pro-life and pro-choice is probably the best one we can find forever, and it's really hard to find enough pairs like that. So what we decide in the end is that when there's no pairs, how about just having no pairs and treat them as just two set of words, one set from Democratic Party, another one from Republican Party. How about this? And so we change the loose according to just like our idea is just like previously we treat each pair differently, and now we kind of take an average of everyone inside here, take an average of everyone inside here, and expect the average to have similar relation. This is the thought we have for the pairs. And it turns out that the standard G and Globe loose looks like it works good at the first glance, but actually it's not. Considering the polarity dimensions, it doesn't look satisfying, because it looks like those words that are not included in the polarity pairs, they didn't capture adequate polarity information. It looks like it's only those pairs are trained to have some polarity score, and other words are just, all of them are just not polarity related. This is the result, showing that this kind of model probably doesn't get along with our data set pretty well. But using the set version, it's still not really working well, and looks even more weird. Like everything looks like it's messed up together, which is not what we expect to have. And we also evaluated it by like averaging those words in a sentence, just taking a simple average of the words in a sentence as the sentence level representation, and pass this representation to an ordinary MLP classifier, and try to tell the difference of the, like, from which party do the poster who posted this tweet came from. And the accuracy is not high compared with this baseline, only using the pre-trained globe model. So what does it infer is that it needs to be improved. And the direction we want to go in the future is that we want to change the structure entirely, but we haven't have a very concrete idea in every detail. So haven't fully implemented this part. So in general, what we have in the end is like we want to treat it as a more abstract model that contains that has three tasks being trained together. The first task learns the co-occurrence. The second task learns the second task force this embedding to capture some sort of polarity, and the third part forces this and this, like the two parts of the embedding, to be unrelated with each other. Like it's not leaking the information to the first part, no. And so this is the part that we are still working on right now. And so after that, we do release our current model, or our current data, or our current code here online. You can go find it out. And also we also attach the links here for the G and Globe model, which is pretty useful in this case, like it's almost like our base model. And this autophrase is another very useful tool used for phrase parsing, which means that it automatically recognizes those phrases in your data set. We need that because it's really too hard to find word level pairs. Like if it's phrase level pairs, then it's somewhat possible to find those pairs in the political data set. So that's all we have for now. And thank you for listening. And if you have any question, please feel free to ask.